everyone, I am Advayam from Webyfy Private Limited. Today I am here to introduce you all to three major technologies that we are developing. The first one is Advayam. This is Advayam. Advayam is basically an open source technology that we are developing for students in order to experiment new IoT technologies. And the next one is Reach. This is Reach. Reach is an integrated hardware network for distributed system management. It is an edge technology and also has a dedicated user interface. All of this can be independently configurable over 300 plus sensors. We are also releasing over 300 plus and 50 plus sensors into the market in the very few months. This is our Advayam demonstration setup. It consists of two various Advayam boards, ESP32S3 and RP2040 board. Our demonstration consists of two sections. One section is a simulation setup and other is a real-time environment setup. The setup is simple. The data simulation board acts as the testing ground while the Advayam ESP32 and RP2040 are the boards we are putting into test. Everything you see is monitored and controlled through the unified user interface shown here. Okay, first let's focus on the real world environment. Here we have four live sensors: LDR for ambient light, PIR for motion, sensors for AC voltage and DC current. So these are the two types of sensors producing analog and digital output. So now we are going to see the data produced by these sensors in the hardware test panel shown here. These are the sensor reading that is shown. The AC voltage, DC current values are shown here. The LDR and motion sensor stages are also seen here. Now we are going to see our simulation setup. To test the capabilities and reliability of our board, we use a data simulation board as shown here. It generates digital output and analog output and also can communicate over I2C, UART, SPI and is able to receive digital and PWM inputs. Advayam ESP32S3 board and RP2040 board, which are able to send data to the digital terminal board through four terminal boards. There are four types of terminal boards: digital terminal board, relay terminal board, analog terminal board and the communication terminal board. The data from the digital terminal board is sent to the MQTT broker via ESP32 board. These data are shown here. So it consists of analog channels, digital outputs, digital inputs and also PWM control is provided here. Then there is a section for ESP32 and RP2040 and also the sensor readings are shown before. The first section is the digital output section. If we give a particular sequence to this pins such as D1, D2, D3 are turned on and D6, D7 are turned on here. So in the output section we can see the D1, D2, D3 and D4 are updated here are shown here. So the D5, D6, D7, D8 sections are shown as here. D5, D6, D7 and D8 are updated here. Now we are going to the analog channels. We have four major channels, channel 1, 2, 3 and 4. The values can be changed from 0 to 3.3 voltage level. So if you adjust the voltage level here, the changes are reflected in the right side. as shown here, the changes are reflected in the right side also. So as we change all these values, the changes are reflected in the ESP side and also the RP2040 side. Now we are going to the PWM control. So we turned on here channel 1 and channel 2. As these are changes, these values are reflected over this side. Here we can see the frequency is updated here. This is the overall setup of Advayam. Now we are going to see the system of reach. It has a DCU, which is the data collision unit, and it also has 4 terminal boards. First one is relay terminal board, which is connected to 5 set of LEDs. Next, the analog terminal board, which is connected to a set of analog sensors, humidity, temperature, current and voltage sensors. The next one is digital terminal boards, which is connected to different sensors such as shock, thermal trend sensor, limit switch and NVR sensor. It also has a camera in which all the data is collected. This is a communication board. In this setup, we use USB to communicate to the Raspberry Pi shown here. So we can also communicate via other protocols such as Wi-Fi, Ethernet, etc. This is the interface of reach. First, we can see the camera. When it is turned on, we can see it here. The AC voltage, DC voltage, etc. are measured from those sensors. All the data from the sensors collide and reach to the Raspberry Pi. We also have different sensors here. So first one is emergency switch. First, I am going to show you emergency switch. So when it is turned on, we can see here. Second is limit switch. When it is turned on in the hardware side, it is reflected here. The next one is door. It can also be opened and closed. The light detector, the thermal switch. When we place a hand or something warm, it is turned on. The next is shock. When some shock happens to the hardware side, it will be turned on and off. Then there are various LEDs. In the UI, when that LEDs are turned on one by one, it is reflected in the hardware side also. The LED 1, 2, 3, now 4, then 5 is turned on. Let me introduce you to different sensors that we have designed and developed. So first we are moving to the major sensors, single phase energy meter to 3-phase energy meter and DC energy meter. Also we have developed different current sensors, DC current, AC current, etc. Also we have developed different digital sensors and capacitor sensor, motion sensor, load cell amplifier sensor, etc. This is a sensor products listing document for release in 2025.
The enclosures of the assembly are designed with several considerations, including utility, external environment, aesthetics, etc. The base design is optimized to bring about various use cases within the same design structure.